Large language models do not possess a database of verified facts. They are autoregressive probability engines trained to predict the most statistically plausible next token. In creative writing, statistical plausibility produces poetry. In enterprise engineering, it produces catastrophic failures, invented API endpoints, fabricated medical citations, and silent numeric inaccuracies. When an LLM produces syntactically flawless nonsense, we call it a hallucination. Today, we break down why hallucinations happen at a mechanistic level, and how to build automated verification guardrails to eliminate them in production. To fix hallucinations, you must first categorize them. Production hallucinations fall into two distinct buckets: intrinsic and extrinsic. Intrinsic hallucinations directly contradict the context you supplied. Your retrieved context says the refund window is 30 days, but the model outputs 60 days. Extrinsic hallucinations introduce information that cannot be verified from the context at all. It may not contradict your text, but it invents ungrounded claims, like citing an unverified compliance certification. Debugging your pipeline requires tracking both. Intrinsic errors mean your prompt constraints failed. Extrinsic errors mean the model leaked parametric memory past your grounding filter. Why do these failures occur? First, token drift. Because generation is conditioned autoregressively on preceding tokens, an early minor deviation compounds, turning a small assumption into a fully formed confabulation. Second, sampling entropy. High temperature flattens the probability distribution and forces the model to sample lower probability tokens, where creative variance replaces strict determinism. Third, sycophancy. Alignment techniques like RLHF bias models toward agreeableness, so a leading question gets validated instead of corrected. Your first line of defense is your inference configuration. For factual extraction, data parsing, and zero-shot question answering, set your sampling temperature to 0. Temperature 0 enforces greedy decoding. Argmax token selection at every step, eliminating random sampling noise. Next, constrain the output space. By enforcing a strict JSON schema or context-free grammar constraints, you prevent the model from appending conversational filler or unconstrained narrative tangents where hallucinations thrive. If a model cannot emit arbitrary free-form tokens, it has significantly fewer pathways to hallucinate. In mission-critical enterprise systems, you cannot trust a raw generation. You must verify it before serving it to the end user. Implement an automated natural language inference verification layer. First, a lightweight parser decomposes the model's draft output into isolated atomic claims. Next, a fast cross-encoder model evaluates each claim against the retrieved context passages, classifying the relationship as entailment, contradiction, or neutral. If any claim yields a neutral or contradictory score, the pipeline intercepts the payload, strips the unsupported claim, triggers a targeted regeneration pass, or flags the response for downstream handling. For complex analytical tasks where a fast cross-encoder is not expressive enough, implement the chain of verification pattern, or CoVe. Instead of generating a monolithic answer in one shot, the architecture executes 4 discrete steps. Step 1. The model generates an initial baseline response. Step 2. The system prompts a verification agent to formulate targeted, independent fact-checking questions based on that draft. Step 3. Those questions are answered strictly against the source material, completely isolated from the draft to prevent confirmation bias. Step 4. A final synthesis step merges verified facts into the output, explicitly pruning any claims that failed the check. Never underestimate the power of defensive system prompting. The single biggest driver of hallucinations in enterprise RAG pipelines is forcing the model to answer when the context does not contain the answer. You must design a deterministic escape hatch. Explicitly instruct the model that acknowledging insufficient evidence is the correct behavior, and provide few-shot examples of refusing to answer on partial context. Combine this with provenance tracking. Require the LLM to output inline source citations matching exact context IDs. If an assertion cannot be mapped to a valid citation tag, your guardrail immediately drops the token stream. You cannot engineer what you do not measure. Factual integrity must be continuously tracked in your CI/CD pipelines. Use standardized frameworks like RAGAs or TrueLens to evaluate faithfulness, the ratio of supported statements to total statements in the response. Run automated synthetic test suites against your knowledge corpus before pushing prompt updates or model changes to production. If an update raises contextual precision but drops faithfulness by even 2%, fail the build. A fast, fluent model that lies 2% of the time is unusable in enterprise production. Hallucinations are not an unsolvable mystery. They are an expected characteristic of statistical language modeling that must be counterbalanced with deterministic engineering. Set your temperature to 0. Enforce strict structured outputs. Validate atomic claims with Cross-Encoder NLI. Build negative fallback escapes. And gate every production deployment with continuous faithfulness evaluation. Stop hoping your models tell the truth. Build the architecture that guarantees it. This is day 17 of the 100-day AI engineering series. If this helped you build more reliable systems, hit subscribe, and see you in the next one.